Welcome to The Story Lantern. In today's lecture, we explore the fascinating world of LiDAR systems, learn about topographic, bathymetric, mobile, terrestrial, and UAV LiDAR, different platforms, how LiDAR works, point clouds, and practical surveying applications. Let's begin. Discover LiDAR with us. LiDAR. LiDAR, short for light detection and ranging, is a powerful technology for measuring the shape and position of objects using laser pulses. It sends rapid pulses toward the ground or other targets, records their return time, and converts those measurements into accurate three-dimensional information. Today, LiDAR is widely used in mapping at scale. The first major type is topographic LiDAR. It is designed to capture the elevation and shape of the Earth's land surface. From millions of laser measurements, it can create dense three-dimensional point clouds that represent hills, valleys, roads, buildings, and vegetation. Surveyors use these data to produce digital elevation models. This matters. Topographic LiDAR is especially valuable where traditional ground surveying would take too much time. An aircraft or drone can scan a large area and collect elevation measurements systematically. Because the laser can record many points in a short period, the resulting dataset can reveal subtle changes in terrain. This makes it useful for at-scale. The second type is bathymetric LiDAR, which is designed to measure underwater terrain in shallow water. Specialized laser wavelengths can pass through water and return from the seabed, allowing surveyors to map riverbeds, lakes, coastal zones, and submerged features. Bathymetric LiDAR is useful for hydrographic surveys, coastal management. Clearly, a major advantage of bathymetric LiDAR is the ability to collect information across broad shallow water areas without sending survey teams everywhere by boat. The measurements can help identify channels, sandbars, submerged structures, and changes in the seabed. When combined with other hydrographic observations, the data provide a strong at-scale. The third type is mobile LiDAR. In this arrangement, the laser scanner is mounted on a moving vehicle such as a car, van, or truck. As the vehicle travels, the system continuously captures millions of points around the road corridor. These points can represent pavement, signs, buildings, bridges, poles, trees, barriers, and other roadside at scale. Mobile LiDAR is particularly effective for transportation and urban surveys because data can be collected while the vehicle is moving. It supports road inventory, asset management, corridor mapping, smart city projects, and infrastructure inspection. Compared with many conventional surveys, it can cover long road sections quickly and produce today. The fourth type is terrestrial LiDAR, often called ground-based LiDAR. Here, the scanner remains stationary on a tripod while it records its surroundings. The system can capture extremely dense and accurate three-dimensional data from buildings, structures, cliffs, tunnels, industrial facilities, and archaeological sites. Multiple scanner at scale. Terrestrial LiDAR is useful when very high detail is required at close range. Engineers can document deformation, construction progress, structural conditions, and difficult-to-access surfaces. Archaeologists can record monuments and heritage sites without touching them. Because the scanner can measure millions of points, even small, this is useful. The fifth type shown is UAV LiDAR, or drone LiDAR. A compact laser scanner is mounted on an unmanned aerial vehicle and flown over the survey area. This combination provides high-resolution measurements while keeping the platform flexible and efficient. UAV LiDAR is particularly useful for small to medium-sized sites, agriculture, clearly. LiDAR platforms. The first platform is airborne LiDAR. In this system, the scanner is carried by a manned aircraft and can cover very large or inaccessible areas efficiently. Aircraft-based surveys are suitable for regional topographic mapping, forest assessment, flood modeling, disaster management, and large infrastructure projects. The platform provides at-scale. Airborne LiDAR is especially valuable when the survey region is too large for practical ground operations. A planned flight can collect measurements across hundreds or thousands of square kilometers, depending on the project. Modern systems also combine LiDAR with navigation and positioning equipment, allowing each laser return to clearly. The second platform is UAV, or drone LiDAR. Drones can carry lightweight laser scanners and fly close to the ground, making them suitable for smaller areas where high resolution is more important than regional coverage. They are flexible, comparatively economical, and can operate from locations that are difficult for conventional survey for mapping. Drone LiDAR also offers an important operational advantage: rapid deployment. A survey team can transport the equipment to a site, establish control points, plan flight lines, and collect data without requiring a large aircraft. However, the quality of the final product still depends on flight planning, positioning accuracy today. This adds value. The third platform is mobile or vehicle LiDAR. The scanner is mounted on a car, van, or truck and collects measurements continuously as the vehicle moves. This platform is ideal for roads, streets, bridges, urban corridors, and other linear infrastructure. It can capture the surrounding environment from multiple directions, producing a 4 mapping. The fourth platform is terrestrial or tripod LiDAR. It is a static ground-based platform that normally provides very high accuracy and dense point data. The scanner is positioned at carefully selected locations and records the surrounding scene. Several scans can be registered together to cover large structures or complicated spaces for mapping. The fifth platform is marine or boat-based LiDAR. In this configuration, the scanning system is installed on a boat or ship and is used for coastal mapping, port and harbor surveys, shoreline studies, and selected shallow water environments. The moving vessel provides a practical platform for collecting measurements along waterways while at scale. How LiDAR works. Now let us look at how LiDAR works. The process begins when the sensor emits a rapid laser pulse toward a target. The pulse travels through the air, reaches an object or surface, and reflects back toward the sensor. The system measures the travel time of the pulse and combines that information with the sensor's position and orientation to at scale. After collection, thousands or millions of individual measurements form a LiDAR point cloud. Each point can contain coordinates and additional information such as return intensity, classification, or return number. Software processes and filters the raw observations, removes unwanted noise, and separates useful features. The resulting, this matters. A LiDAR point cloud can be interpreted in different ways depending on the application. A topographic view emphasizes the shape of the land and can reveal hills, drainage patterns, slopes, and terrain breaks. An infrastructure view can show roads, bridges, buildings, poles, and other constructed features. A vegetation view can reveal, this is useful. Summary. LiDAR has several important advantages. It can collect dense three-dimensional information rapidly, measure large areas, and capture complex geometry that may be difficult to survey manually. It can also operate day or night because it supplies its own laser illumination. Nevertheless, LiDAR is not automatically perfect. For a successful LiDAR project, the workflow should begin with clear objectives. The survey team must decide what needs to be measured, which platform is appropriate, the required point density and accuracy, and how the area will be accessed. After collection, positioning data and control information are checked, point clouds are processed clearly. In conclusion, LiDAR is much more than a laser scanner. It is a complete measurement technology that connects sensors, positioning, data processing, and three-dimensional modeling. Topographic, bathymetric, mobile, terrestrial, and UAV LiDAR describe different ways of collecting information, while airborne, drone, vehicle, tripod, and marine today. Thank you for watching this LiDAR lecture on the Story Lantern. We hope you found the discussion on LiDAR systems, platforms, point clouds, and surveying applications useful. If you enjoyed the video, please like, share, and subscribe to the Story Lantern for more informative lectures and learning content. See you in the next video.